Hello, welcome back. This is the section 8.5, part 2, the second part of it, where I demonstrate the next four examples. So let's start again here with problem 1E. It's similar to problem 1D. As you remember that D is not possible to proceed further because you have a positive radicals here, and the right side is equal to -2. You cannot take a square root and have a -2 at the answer, so it's not possible to proceed. Let's start with part E here. We're going to do the same thing now. And wait, is that the same problems here? That looks like the same problem, so I guess we just go ahead and skip part E here and proceed with part F. Okay, so when you solve radicals, your very first thing is to make sure that there is one radical on one side. Okay, it doesn't matter what you have on the other side as long as you are able to isolate one radical on one side. So I'm gonna go ahead and add s to the other side so I can isolate the radicals. Okay, add s. That's gonna give me s minus 3 on the right side, and the square root of 3 minus s on the left side. Then once you are able to isolate that, the next step you do is square both sides. Okay. So when you square the left side, you're gonna end up having 3 minus s. Okay. Without thinking, that would be s. Okay. You also need to remember that this is not s squared minus 9. Okay. This is actually a FOIL problem or a table problem where it means that it's s minus 3 times s minus 3. Okay. So let's proceed to one of the methods, the table method, the FOIL method, or any other method that you have learned and feel comfortable doing. So this is going to be s squared minus 6s, and then it's going to be plus 9. 3 times 3 is 9. Okay, and then you have a 3 minus s. Well, when you look at here, you can see that it's a radical, it is a quadratic problem, so you know that one side has to be equal to 0. So I go ahead and subtract 3 and add s to both sides. I'm going to do it at the same time. Okay, so minus 3 plus s. In doing so, I have one side equal to 0, okay, which is the left side, and the right side is going to be s squared. 6 plus 1, negative 6 plus 1 is negative 5, and then 9 minus 3 is 6 plus 6. Okay. You can try to solve by factoring here. Okay. Negative 5 means that I have s squared, not s squared. I would have s and a 2 and a 3. And the one way to get a negative 5 is negative 2, negative 3, and you can see that negative 2 times negative 3 gives you positive 6. So the possible answer for this is s minus 2 equal to 0, or s minus 3 equal to 0. So that means either s equals to 2 or s equals to 3. Okay, I have to go back and double check that. Okay, and I can use the original problem here. Let's start with s equals to 2. If s is 2, I'm going to have 3 minus 2, which is the square root of 1. And the square root of 1 minus, square root of 1 is 1. 1 minus 1 is going to be 0. Is 0 going to be equal to negative 3? Not quite. So this is an extraneous solution right here. Okay. Okay, let me try again to show you physically here. I have the square root of 3 minus, and my s is 2. Okay, so I'm going to put a 2 here. And then I have a minus. Oh, that's not 1, it's a 2. Hold on, let me take a look at this. Here I have a 2. If I put a 2 here, I would have it's equal to negative 3. So when I have the 3 minus 2, which is 1, square root of 1 is 1, 1 minus 2 equal to negative 3. Well, that still doesn't work because negative 1 is not equal to negative 3. So yes, that is still a Schrödinger solution. Okay, let's try 3. If I have 3 minus the number 3, and then I would have minus a 3, would that be equal to negative 3? I have a question. Well, 3 minus 3 is 0. 0 minus 3 equals negative 3. Yeah, that's average. Okay, so this would be the only solution here for that problem. Okay, in the event that you have two radicals like this, as long as you have one of them isolated, you can go ahead and proceed to the second step in the strategy, which is to square both of it. Okay, when you square everything on both sides. So on the left side, you end up having s plus 12. On the right side, keep in mind there are two terms, this one and this one. So you're going to end up having 3 squared, and then time with the number that you have here, which you're going to bring it down as s plus 4. Okay, simplify the right side a little bit. You're going to have 9 s plus 4. And then you have on the left side s plus 12. Here it's going to be 9s plus 36. And this is s plus 12. This is a linear problem, so you can just, have variable on one side and number on the other side. I have a 9s here, so I'm going to subtract the s. Okay, so that I end up having 8s plus 36. And then this one right here will be equal to 12. And I go ahead and put, subtract 36 to the other side. And that's going to give me 8s equal negative 24. If I solve for s is going to be negative 3. Okay. Before I box the answer, let's go back and double check the work. Here, if I have s is negative 3, I'm going to end up having a negative 3 plus 12. Is that going to be equal to 3 times negative 3 plus 4? Well, let's find out. Negative 3 plus 12 is going to be a 9 here. Okay, and then 3, this one right here is equal to 1. So square root of 1 is 1, 3 times 1 is 3. And square root of 9 is also 3. So that works. This is my answer. Okay. The last example. Well, why don't you try the last example yourself? Okay, because it's similar to G. And in terms of checking for the solution, send me an email. Okay, take a screenshot, text it to me, send me an email, and I will double check your work for you. Okay.